Welcome to Unit 8, Lesson 4, Prove It with Algebra. So we're going to start with the ready number 1, and the first thing we're going to do is find the values that will make the equations true. So to start off, we are going to solve for A and then figure out what it is that A can be. So the first thing we're going to do is subtract 4 from both sides, minus 4, and we end up with A squared equals 5. We'll copy this down a little bit bigger. A squared equals 5. Now we know that if we have A squared and we want to get A by itself, we have to take the square root of both sides. So the square root of both sides, but we know that when we take the square root, we have to take the positive or negative square root. And that's actually going to come very handy here. You're going to see that this doubles the possible solution. So A squared, right? We take the positive or negative square root of that, and we end up with just A, because when we take the positive or negative square root of 5, we have either the positive or negative square root of 5. You might think, well, that doesn't make much sense. What do you mean? This is our answer. There's two different answers here. Because if the square root of 5 is, let's say it's maybe it's 2.2. It's probably pretty close to 2.2. If we square 2.2, we'll get 5. But if we square negative 2.2, we'll also get 5. So that's why there's two different answers, because all we know is that whatever we have for A, whenever we square it, it becomes 5, which means A could be a positive or a negative. So that's why we have A equals the plus or minus positive or negative square root of 5. Let's keep going. 4 plus B squared equals 16. All right, let's do this in a different color. 4 plus B squared equals 16. Let's first subtract 4 from both sides. Minus 4 from both sides. So we get B squared equals 12. And we'll write this up here. B squared equals 12. Now we're going to plus or minus square root both sides. Oh, just kidding. Don't want to put a dot there. Now we have just B by itself equals the positive or negative square root of 12. If we wanted to simplify this even further, right? If we wanted to go further with this, we could say that B equals the positive, bear with me, the positive or negative of, what would it be, 2 root 3, plus or minus 2 root 3. We could do that as well. That's more simplified. Both of these, right? These are equivalent, just one's more simplified. So that'll work as well. For number 5, here we go. A squared plus 24 equals 49. Let's go back to our green here. First thing we're going to do is take away 24 from both sides. Minus 24, minus 24. We're left with A squared equals, what is left? 25 is left. So A squared equals 25. Let's write this again. A squared equals 25. We have to take the positive or negative square root of both sides. And we get A equals positive or negative. Now we know the square root of 25 is 5, so it's positive or negative 5. So don't fall into the trap. Just because you know that A squared is 25, obviously that means that A is 5, right? No. Could be positive 5 or negative 5. So you have to always remember you're taking the positive or negative square root when you undo a variable squared. When you're undoing a square, you have to take the positive or negative square root. All right, 8. 9 plus B squared equals 49. Let's subtract the 9 from both sides. B squared equals 40. B squared equals 40. Plus or minus square root on both sides. b equals plus or minus square root of 40, which is equal to b equals 2 plus or minus 2 root 10, because we can take a 4 out of that. If we take a 4 out of a square root, it becomes a 2. So 2 plus or minus the square root of 10. Or sorry, positive or negative 2 root 10. There we go. All right, that is our ready complete. Use the figure for problems 9 through 11. Okay, let's go look and see what our figure is. Here we go. Here's our figure. Is quadrilateral PQRS a rectangle? Is it a rectangle? Well, let's first, if we're going to be classifying a quadrilateral, I'd say let's first figure out what all of our slopes are. Right, let's figure out slopes and let's figure out lengths. All right. So I think this is going to help. We're going to have to figure all this out anyway. So let's just figure out. We'll do slopes in green, and we'll do lengths in purple. So slopes, we have PQ, QR, RS, and then SP. And same thing over here for our lengths. We could have PQ, QR, oh, too close on that one, RS, and SP. Okay, so let's do this first. From P to Q, oh, we should also probably label our points. Let's have that in blue just so we know what we are doing here. Point P seems to be at -7, comma, how high is it? 1, 2, 3, -7, comma 3. Point Q seems to be at -2, comma 7, -2, comma 7, comma 7. R appears to be at 2, 2, 2, 2, 2, 2, and S looks to be at -1, 2, 3, -3. That might have been bad. I'm not sure what I just did. -3, comma, where is it height-wise? It seems to be at -2. All right, -3, -2. All right, now we can go back to solving our slopes. So what is the slope from P to Q? Well, the change in Y, right? How high do we go? We're going up 4 over 1, 2, 3, 4, 5. Up 4 over 5. So the slope is 4/5. From Q to R, it's going to be negative something. It's over, or it's up 1, 2, 3, 4, 5. So this is 5 and 4, right? 5 and 4. Oh, it's really not letting me write there. There we go. 5 and 4. So this is -5 over 4. For R to S, Well, we're going from +2 to -2 vertically. So this is going to be down 4, and this is going to be 1, 2, 3, 4, 5. So that's another, right? If we were going down 4 and left, so this is the same as going up 4 and to the right 5. So that's, right, a positive slope because it's going up to the right, down to the left. So that's going to be 4/5 again. And finally, SP, we have, what's our slope? It's going to be negative because it's going right down to the left, right? It's got one of these going, or I guess this looks like positive to you, doesn't it? Because my camera's flipping it. Anyway, it's a negative slope. I hope you can see from P to S, right? From P to S going down like this, that's going to be a negative slope. Oh, it didn't like that. That's okay. So it's going to be a negative slope, but if we go from P to S, we go down 1, 2, 3, 4, 5, right? Down 5, and then over 1, 2, 3, 4, and over 4. All right. Now let's look at the lengths. We can actually do something creative here for the length and do a little bit less work, right? And what is that we're going to do? Well, let's imagine that all of these triangles are actually right triangles, right? Let's put a right angle here, a right angle here, a right angle here, and a right angle here, because we are just forming a bunch of right triangles. And by doing that, we know that we have, oh, sorry, I didn't label this. This is down, sorry, that was down 5, wasn't it? Yep, that was down 5. So by doing this, right, we now have a bunch of triangles that all have one leg that's 5, one leg that's 4, and then some hypotenuse. Now we don't know what that hypotenuse is going to be, right, the longest side, but we could figure that out using Pythagorean theorem, right? 5 squared, right, so for PQ, right, just looking at this triangle now, right, we know that the longest side is going to be 4 squared plus 5 squared. Right, we know that this is going to be, right, if for a right triangle where we have a 4, a 5, and something, we know that 4 squared plus 5 squared is going to equal that last length squared. So what's 4 squared plus 5 squared? Well, 4 squared is 16, plus 5 squared is 25, and that's question mark square, right? That's whatever the length is. 16 plus 25 is 41, so 41 is our mystery length squared. And now if we take the positive or negative square root of 41, we should get our answer, right? But we're not going to take it. I know we just talked about always taking the positive or negative square root because you're going to miss out on a solution. But that is only in instances where it's purely numbers and there's not something drawn. We're talking about the length of a segment, right? The length of a side. The length of a side can never be negative. So we're only, in this case, we're only going to take the positive square root. So the square root of 41 equals, right, our mystery length. So we can fill that in. Square root of 41, square root of 41, square, oh, wow. The light turned off and it got me. 1 second, please. There we go. All right, we're coming back. The square root of 41 is that length, and the square root of 41 is that length. So let's go over to our lengths as well. Sorry, it should be over here. Root 41, root 41. That didn't work. 41, root 41, and root 41. So those are our lengths. So let's see. All of our lengths are the same, which means that as far as it being a rectangle, the opposite sides are the same length, so that works. Now we just have to make sure are the adjacent, right? Our adjacent sides, right? These two are adjacent and those are perpendicular, right? These two are adjacent, and because -5/4 is an opposite reciprocal of 4/5, right? Those two are perpendicular. These two are adjacent, and they're perpendicular. And finally, right, these two are adjacent, and they're also perpendicular. All right, so all four of them are perpendicular. So is quadrilateral PQRS a rectangle? Yes. It is a rectangle, right? Because it has 4 right angles. Which is really all we need. 4 right angles make something a rectangle, but we'll keep going. And opposite sides parallel. Oops, sorry, don't need that. Parallel and congruent. That is a rectangle, so that works. And we have the math up top to back it up. Is quadrilateral PQRS a rhombus? Is it a rhombus? Well, what does a rhombus mean? Everybody know? A rhombus means that it has to have, it doesn't matter about the angles. It's just if all of the sides are the same length. Yes. All 4 sides congruent. And rhombuses or rhombi, if you have, like, any rhombus is a parallelogram, so all 4 sides congruent. And opposite sides parallel. Is quadrilateral PQRS a square? Yes. All sides congruent and all right angles. Right? Oh, so question 12 was going to ask us about this quadrilateral, but we are skipping question 12, so let's go to 13. Find the exact perimeter of each figure, then round your answer to the nearest thousandth. So find exact and then round. All right, exact first, then round to the nearest thousandths place. All right, so that's fine. Find the exact perimeter. All right, so we don't care about slopes and angles now. We're just doing perimeter. So this is the point. Right, let's take special note. This is the origin. All right, that's our origin. Which means that this is the point. Let's start here. This is -5, 2. Actually, let's do a little bit less work here, right? Instead of brute forcing and doing all the calculations, let's really try to make this more graphical. Let's draw some triangles here, right? I would rather use Pythagorean theorem, right? Rather use Pythagorean theorem and make a bunch of little right triangles in order to find distances instead of plugging stuff into the distance formula. So let's write Pythagorean theorem up at the top and in red. Right, Pythagorean theorem, right, if we have a right triangle, with a, b, and c, then a squared plus b squared equals c squared, right? This is going to help us do a lot less work. So to start off, we go, here's a right triangle, right? Wasn't really well drawn, but that's okay. 4 there, and then 1, 2, 3, 4, 5, 6, 7. 7 here. So that's a 4, 7, and we don't know what the missing distance is yet, but we can find it. So 4 squared, and we can do that over here. 4 squared plus 7 squared, right? And we'll call this, what do we want to call this one? Let's just leave it blank. We don't know. It's something squared. We'll just call it, we'll just use x. We'll just call it x squared. We'll say that this is going to be, yeah, we'll call this x. That's going to be our x. All right, 4 squared plus 7 squared equals x squared. And we're doing this in green. We'll switch colors for the other one so it's easy to keep track of. So 4 squared is 16 plus 7 squared is 49 equals x squared. 16 plus 49 is 65. So 65 equals x squared. Then we square root both sides. So the square root of 65 equals x. All right. So we're putting it in square root of 65. All right. Square root of 65 is in. Let's change colors. Let's do this one. What's this one? 1, 2, 3, 4, 5, 6. It's a decrease of 6, right? So we're going down 6 and over 2. So let's set it up again, right? 6 squared plus 2 squared equals, and you know what? We'll just use x again. That's fine, but it's a purple x, so it's different. Equals x squared. All right, 6 squared is 36. 2 squared is 4. Right, so we have 40 equals x squared. And we square root both sides. 40 equals x. Right? The square root of 40 equals x. So this x is the square root of 40. Excellent. Let's switch to let's go to orange. Let's go to a nice orange. All right. Right, so we're going over 1, 2, 3, 4, 5, 6, 7. We're going over 7 and up 1, 2, 3, 4, up 4. So we have 7 squared plus 4 squared equals x squared. We're doing another x. This is going to be x again. 7 squared is 49. 4 squared is 16. Equals x squared. Haven't we already done these numbers out? 7 and 4? We did, right? It matches the green. Right? So save yourself a little bit of work. I mean, we'll still copy it down, but if you notice that those are the same, right, you could just jump ahead. But let's go with 65. Wow. Let's go with 65 equals x squared. Square root of 65 equals x. All right, so the square root of 65 is here. And finally, we'll go to maybe a light blue. That'll contrast nicely. It's 2 across, and then how many down? 1, 2, 3, 4, 5, 6. We've already done this 2 and 6. We have. All right. 6 squared plus 2 squared equals x squared. You guessed it. We're using x again. Equals x squared. 36 plus 4 equals x squared. 40 equals x squared. The square root of 40 equals x. Square root of 40 equals x. All right, and now the last thing is the perimeter is all the way around. So let's switch to something we haven't used yet. What have we not used yet? I don't actually know. Let's go to a dark blue. Let's go to a dark blue. We'll go down over here. Right. Perimeter. Right, and that's going to be square root of 65 plus square root of 40 plus square root of 65 plus, plus, there we go, plus the square root of 40. Right, that's our perimeter. It's all the way around. So that's the exact. Now, rounded to the nearest thousandth, well, I'm not sure we can do that in our head, at least not rounded to the nearest thousandth. So we would take out a calculator. In fact, you know what? I want a better calculator than even my phone, so I'll bring up this. And I think you'll be able to see this as well. It should be a calculator that pops up. But let's see. Maybe it doesn't pop up. It probably doesn't, actually. Oh, no, you should be able to see it. I think you can still see it. All right, let's see. If we go to, let's clear out of this. I'm not sure what it's doing right here. So let's go quit out of that. And we wanted the square root of 65 plus the square root of 40 plus the square root of 40 plus the square root of 65 plus the square root of 40. All right, that's what we wanted. We hit enter. 28.77362614, and it probably keeps going, but that's all it's going to show us. And if you remember, we want rounded to the nearest thousandth, right? If we go back, right? Let's go back and look, right? It said, round your answers to the nearest thousandths place. All right, thousandths place. So if we go here, the thousandths place would be 28.774. So that's what we're going to rate, 28.774. Twenty-eight 28.774. That is our perimeter rounded to the nearest thousandth. All right, let's go see what else we're working with. Looks like we're skipping 14 and 15, going right to 16. All right, we've got straight lines, so we can use Pythagorean theorem again. We will go this one first, right? What's the length? What's the length, or what's the height here? Sorry, the length of the vertical portion. 1, 2, 3, 4, 5, 6, 7, 8. And the horizontal portion is 2. So 8 and 2. All right, we can do that out. 8 squared plus 2 squared equals, you know what, let's use c here. C squared, let's do that. 8 squared is 64, so that's 64 plus 2 squared is 4 equals c squared. So we get 68 equals c squared, and then the square root of 68 equals c. All right, so this portion here is the square root of 68. All right. Let's go to a different color. Let's go to the orange again. 1, 2, 3, 4, and then down 3. 4 and 3, and this is going to be another C. All right. 4 squared plus 3 squared equals C squared. 16 plus 9 equals C squared. 25 equals C squared. Square root of 25 equals C, which means 5 equals C. So we can just replace this with a 5. And maybe we know that there's a special kind of right triangle, right? There are a couple of right triangles that are special. This one is called a 3, 4, 5 special right triangle. Because if your legs are 3 and 4 in length, then the hypotenuse is going to be 5. All right, and last, let's go to, we'll go back to our green. That's fine. We go over 2, 1, 2, and up 1, 2, 3, 4, 5. There we go, up 5. So over 2 and up 5. And you guessed it, we're going to use C again. So 2 squared plus 5 squared equals C squared. 4 plus 25 equals C squared. 29 equals C squared. And then C equals, well, I guess the square root of 29 equals C. There we go. So this is going to be the square root of 29. All right. So our perimeter, let's see what we're doing. I guess we'll do it in light blue. Here we go. The perimeter, the exact perimeter is 5 plus the square root of 68 plus the square root of 29. 5 plus the square root of 68. Nope. Plus the square root of 29. All right, that is the exact perimeter. Now, what is the rounded perimeter? Well, let's go over and check. Let's clear this, and we'll go 5 plus the square root of 68. Oh, hang on, can't have that there. 5 plus the square root of 68 plus the square root of 29, right? Those were our numbers, 68 and 29. Let's go back and check. 5, square root 68, square root 29. 5, square root 68, square root 29. Okay, those are the right numbers. It's good that I remember that. So 18.6313. So we're going to round this to 18.631. 18.631. 18.631. All right, there we go. 18.631 is our rounded answer, right? Rounded to the nearest thousandths place. And finally, what do we have here? I think this is the last one, is 18. All right, and we have lots of space for this. So here we go. The last question. So this is tricky. Right? We have a circle now. They put a dot for the origin for us, which is good. But they gave us a circle. And they also gave us a bunch of different points. The only point here that we're not going to use is actually the origin. it's just nice that they labeled, right? They put a point on the origin for us, but we do have to check, right? There's no writing on here that says that we can assume that this is part of a circle or anything like that. So what we first have to do is figure out the distance here, right? As well as the distance here. And then we have to figure out the distance here. All right, so if we figure out the three distances, we'll call them A, B, and C. If we figure out A and B and C, if we can figure out all of those and they're all the same, then we know two things. We know that it's a circle, right? Or that the curved line is in fact a circle. And we know that the center of the circle is that point. All right, so let's do it. Let's start figuring. So this is going to be, that's a 3 and this is too high. This is a 3 and this is too high. And finally this, oops, sorry, not in purple. This is 3 across and too high. So if all of those triangles have the same legs, right, we know that the distance for A, B, and C are all going to be the same. So let's just stay in our purple, that's fine, right? But we know that A equals B equals C because all the right triangles are 2, 3, and then something else. So they're all going to be the same. Whatever that x is, they're all going to be the same. So let's figure out what that is. 2 squared plus 3 squared equals a squared. 4 plus 9 equals a squared. 13 equals a squared, which means that the square root of 13 equals a. All right. Oh, I don't want to circle that because that's not the final answer. That's important. Right, and they're all the square root of 13. Okay, it's good that we have that up there. Which means that the perimeter of the entire thing is going to be B plus C, right, which is the square root of 13, right? So let's open up a perimeter tab here. Yeah, let's go over here. The whole perimeter is going to be B, which is the square root of 13, plus C, which is the square root of 13, plus half of the perimeter of a circle, right? Or what's the perimeter of a circle called? Anybody remember? Starts with a C. Circumference. Yep, so half circumference. Circumference. So we have to figure this out as well. So normally the circumference equals, and this is a capital C, so it's different, so that's okay, right? Normally a circumference equals 2 pi r. So a half circumference, right? Right? But a half circumference, so half c, or c divided by 2, equals just pi r. And since we need to add this portion, right? This c over 2 we have to add. So we have to add pi times the radius. And what's the radius of the circle? Well, the radius is just the distance from a point on the circle to the center, which is our A. So our pi r equals pi times the radius, which is the square root of 13. So we're going to go add that, right? Pi times root 13, or we're just going to write it as pi, pi root 13. So this is the perimeter of the entire circle, right? That's, right, both parts of the diameter, right? It's a radius, root 13 is the radius, and the other radius, that's sort of the straight line. And then finally, pi times the radius is that half of the circumference that we had just described. So that's the perimeter. Now we just have to go, oh, lights turned out on me. One sec. Turn back on, please. It's not working. Hang on. Ah, got it. Okay. I had to get just out of frame, but that's okay. So root 13 plus pi times root 13. Let's go look at it. All right. Let's clear everything. First things first, root 13. Root 13 plus root 13 again, plus pi, which has its own little logo, pi times, and if you actually just put the pi logo next to a square root, it'll do the multiplication for you. Plus pi times the square root of 13, and we hit enter. 18.53827, but rounding to the nearest thousandths, that's 3 decimal points, so right, 3 decimal places, that's 18.538, and then it stops, right? 18.538. 18.538. 18.538. Excellent. All right. This wraps up the homework help for Unit 8, Lesson 4. It was helpful.